This is CPM Precalculus, Chapter 2, number 64. So here we're going to let f of x equal to 9 minus 2 to the power of x. So then we're going to let a of f, comma, 1 is less than or equal to x is less than or equal to 3, be the area between the x-axis and the curve. Okay, so our goal is to estimate this area. So part A asks us to graph the function carefully on graph paper using a scale that is about 1 inch for each unit. Alright, so let's go ahead and graph this in our calculator to see what it looks like. Okay, so we have y equals, and then we have 9 minus 2 to the power of x. Okay, 9 minus 2 to the power of x. Let's graph that. Alright, and we're going to look specifically at the region starting at 1 here and ending at 3. Okay, and we want to graph that, and I gave you a sheet that had this graph already. So this right here is the graph of f of x, right? And that's equal to 9 minus 2 to the power of x. Alright, so that's part A. Part A is just to sketch it. So part A is sketched. Right? Actually, it's already graphed for us carefully. Part B says to divide the region into subregions with vertical lines at x equals to 1. So here's x equals to 1. So we're going to put a vertical line here. So I'm going to draw a vertical line here at x equals to 1. Right? There's my vertical line. At x equals to 1.5. So I'm going to put another vertical line here. Right? Then x equals to 2, 2.5, and 3. So I'm just going to draw vertical lines here, here, and here. Okay? Because again, our goal is to estimate the area, and that's going to be between 1 and 3. So it's going to be this shaded area right here, right? All the way until this point here. Okay? So we've done part B, right? Drawn. Let's go on to part C. Part C says to decide with your team how to estimate the area under the curve in each region separately. So let's look at just this area first. Okay, so I'm going to look between the graph here, right? Oops. The graph here and 1 to 5. All right. Oh, I can't draw very well. So I want to find just the area in this region here. All right. So from 1 to 5, I'm going to even write the area of f from, I'm just going to from 1 to 1.5. So x is between 1 and 1.5. And I'm going to say it's approximately, well, how can I estimate it? Well, this I can estimate using like a rectangle, or like I can say it's a rectangle to this height, right, from here to here, and then we have like a triangle up here, something like that. Or I can use trapezoids and say, well, right, I can say this is just one big trapezoid, right, and I can say the area here then is everything shaded in there, and the area of that trapezoid, remember, is 1/2 times base 1 plus base 2 times height, which is then 1/2. Well, the base is going to be 1 to 1.5. No, that's not the base. Remember, the bases are the parallel sides. So the base is going to be this height. Well, at 1, what is this height? Well, at 1, it's just going to be plug 1 into the function. So that's 9 minus 2 to the power of 1. 2 to the power of 1 is 2, so it's 9 minus 2, or 7. So base 1, I'm going to say 7. Base 2, again, is going to be this height. And let me go ahead and erase this so I can write in the height here. Right? It's this height here. And that's just going to be plugging in 1.5 to get this point there. So it's 9 minus 2 to the power of 1.5. I can use my calculator. 9 minus 2 to the power of 1.5. So my other base is 6.17. I'll just approximate it to be 6.17. And the height, remember, is the distance between the two bases, which is from 1 to 1.5. So that's just 0.5. Okay. So let's go ahead and plug this in our calculator. We get 1/2 times 7 plus 6.17 times 0.5. And that's approximately, right, just that region is 3.29 units. All right? So that's how I estimated just this region. Let's do that for every region separately. So for this one, I'm going to use trapezoids for everyone. Okay? So for this next one, I'm going to use a trapezoid going from here to here, right? This is my trapezoid. Right? So the area from 1.5 to 2, 1.5 to 2 is approximately 1/2 base 1 plus base 2 times height, which is 1/2. Well, what's this base, remember, is just the same as it was on the other side. You plug in 1.5 to the equation. So what was that? We plugged in 1.5 and we got 6.17. The other base we plugged in 2, so 6 or 9 minus 2 squared, right, is 5. The height is the distance between these, which is 0.5. 1.5 to 2 is 0.5, right? So let's go ahead and calculate this. Half is 0.5 times 6.17 plus 5 times 0.5. Oops, let me fix that to make it 0.5. Okay, plug that in and I get 2.7925, right, for this area right here, right? And this is, again, units squared. I think I did that wrong in the first one. Yep, that should be units squared because area, remember, is squared units. All right, let's do this region here. I'm going to use a trapezoid again. You can use triangles and squares and rectangles or whatever you would like, but I'm just going to use a trapezoid. Right? So the area between 2 and 2.5, the area between 2 and 2.5 is approximately the area of the trapezoid is 1/2. Well, this base right here on this side is going to be the same as it was in orange over, not there, but over here, right? It's 5. Plus, then I want to plug in 2.5 into the equation to get the height there. So it's going to be 9 minus 2 to the power of 2.5. And so the other base is 3.34 times 0.5. So let's do that math. 0.5 is half times 5 plus 3.34. Close the parentheses, times 0.5. And that's 2.08. Let's round that to 2.09 units squared. All right. Finally, excuse me, I want to find the area of this region. So I'm going to estimate it. It's not straight, but I'm going to just estimate it then with a trapezoid. Right? So this region is just the area between 2.5 and 3. And that's, again, going to be 1/2 base 1 plus base 2 times our height. Right? Because I'm using a trapezoid. So the base over here is 3.34 plus, well, what's the height here? Let's go ahead and plug 2. Now, what is the equation? Let me scroll up. 9 minus 2 to the power of, well, x here is 3. So that's 17. Oops, and that should be minus, right? 2. 9 minus, so that's 1. And the base, the height is the distance between the bases, and this is 2.5 to 3, so that's 0.5 again. And we get 1/2 0.5 times 3.34 plus 1 times 0.5. Okay, so that's 1.09 units squared. Okay, so I did each region separately. There's 1, 2, 3, 4 regions, and I have 1, 2, 3, 4 regions. Okay. And again, there are many ways you could do this. You could estimate it using rectangles if you want, or triangles, or like splitting these up here and seeing that there's like if you split it right here, right, you could say, well, this is a triangle up here and a rectangle down here. However you wanted to do it. So now part D, this is part D. Using any method your team decides to use, find the area of each piece and then estimate. Okay. Oh, so part C was just saying how to estimate it. Well, part C then should just say I use trapezoids, right? And then this right here is part D. So to find the area of F from 1 to 3 is then going to be approximately, I want to add in all of the subregions I found. So it's 3.29 plus 2. I'm going to round this to 79 plus 2.09 plus 1.09. And so add those together, right? Let's go ahead and plug it in. So I have 3.29 plus 2.79 plus 2.09 plus 1.09. So the total area I get is approximately, so let's make sure I write approximate symbols. Ooh, that looks kind of messy. Approximately 9.26, again it's units squared, right? So that is after I add up all of my approximate regions together, my total area between 1 and 3 then for the whole region is approximately 9.26 units squared. If you got something around this, you're great, right? If you get around, it could be anywhere between, I would say, 8 to 11 even. You know, if you get something close to that, it will be a good approximation. All right. So this then ends CPM Precalculus Chapter 2, number 64.